So we were trying to define the groundwater, and as you guys know, groundwater is the water that is found in pores and soil sediments, plus narrow fractures in the bedrock. And this is the water that we use every day in our lives, and is the abundant resource that is drinkable water, and that can be used for all the household things like cooking, like you drink water and all this. These most of these water is derived from the ground. Groundwater, if we see, is the largest reservoir. If you consider any dam or any big mega structure in the world, like the Three Gorges Dam of China, it holds huge amount of water. Similarly, the groundwater in every country, like in Pakistan or any country where we have huge population, most of these population is dependent on the groundwater. So fresh groundwater or fresh water table, I think those guys who live in Sargodha, they know the importance of water, because the water quality in that city is very salty and very bad. It has many hazardous elements in it that are not good for health, like it's not drinkable in some areas, but in some areas like near the university or inside the university, those areas they have very good water quality, and that's why importance of groundwater is immense. And maintenance, and you can call the sustainable development of groundwater is very important. If you don't sustain your groundwater reservoirs will finish one day, and there will be no water for you to drink. So the conditions in future, like in 2030 and in 2030 or 2050, you will see that many areas in the world, they will run out of groundwater. That's why it has the paramount importance, and understanding how groundwater works and how the water forms geomorphic features like erosional and depositional features of the groundwater. So we will need to see them one by one, and we try to understand them. I think some of the students are having problem. Maybe they need to restart their device settings. Okay. Then we go to the, so any water that is entrapped in the pores, in soil, rock, fractures, anywhere inside the earth is the groundwater. In some parts of the world, the groundwaters are shallow. That means you can reach the groundwater very near, like a few meters, and in some parts it's like hundred of meters. A good example to quote here is the city of Quetta. In city of Quetta, the water level or the groundwater level is dropping very fast, and mostly the reservoir is a limestone. And as you drive more and more water out of it, and you waste those that precious reservoir, ultimately it cannot maintain its level. And the other factor is less rains, less snowfall, and ultimately result in very low water level. And ultimately, unfortunately, the day is not far when maybe the groundwater is already finished. Some countries, you can also see Johannesburg, the capital of South Africa, and you can see the importance of water that you can find. Also, you can see videos about Australia or other countries where there is very less groundwater available, and those countries, they really fight for the maintenance and sustainable development of groundwater. Anyways, the geological role of groundwater. Groundwater works as an erosional agent, and it also serves as an equalizer of stream flow. Some of the groundwaters is recharged by streams that are located up in the mountains. So that those streams, they actually percolate. The water actually percolates into the earth and maintains the water table. That's why it is suggested that you always have rejuvenation of the groundwater, like you make some reservoirs uphill that can serve as storage tanks, and those storage tanks can supply groundwater, and they can maintain the amount of water that is available in the stream. Just have a look on the fresh water that is available to the humans. Uh, Most of it is entrapped in ice sheets and glaciers, and unfortunately, due to rise in temperature, these glaciers are melting very fast. It means less and less water will be available for future population, and similarly, the groundwater, that is water entrapped in the ground. And here you can see rate of water exchange. It means this much old years old is the water that you drink, and similarly the entrapped water in the ice sheets is about 8,000 years ago. Similarly, we have lakes and reservoirs. Unfortunately, most of the lakes are not well maintained, and that's why we need to have a very emergency type of uh, work on these reservoirs in order to maintain their viability, in order to maintain that they can serve for future populations. It's not only the problem in our country, it is all over the world. Most of the countries in the world are now water stressed. That means they have less water and more people that use it. That's why each drop of this water is important. Each drop of this water has its say. Understanding the distribution of groundwater, we need to understand the zone of saturation. It is actually a zone where all the pore spaces in the sediments are completely filled with water. That's why this water is actually the groundwater. Here we don't have any air or anything else, just water that is entrapped in the rock, just water that is present in the pores. So the upper limit of this zone of saturation is actually the water table. So if you see water table, the zone of saturation is down there, then there is water table, and then up is the zone of aeration, where we have air and water both in the ground. However, it is not easy to get the water from zone of aeration, or it's equally impossible. But if you see the zone of saturation, the place where we have water table just below the line, you can get the water and flow it to the surface of earth. Then comes the capillary fringe. It is the groundwater that is held by surface tension in tiny passages between grains of soil or sediments, and it is actually the sometimes the water vapors or water is extending from the water table towards the ground surface. We call this thing as a capillary fringe. Zone of aeration, the zone just above the zone of saturation. So the line between the zone of saturation and zone of aeration is called the water table. And in zone of aeration, the most of the pores are filled with air as well as with water. So it is just like not possible for water wells to pump from zone of aeration. Here we have a very good example, interesting illustration, and you can see here we have a groundwater in which all the pores, the blue color is actually the water, and you can see that most of these pores are filled with blue color, and this is the water table, and you can see that the line between the yellow and the blue is the water table, and in yellow there are some pores that are filled with water but very less due to the capillary fringe action. And also we have here the white color is actually the air entrapped in the pores, and you can see that the most of these are in the form of moisture. So it is very difficult for a well to produce from moisture. You always have to whenever you put a well here, so you have already need to cross this line, that is the line of water table. So water table in any area is different, and it depends on various factors like the soil condition, the presence of subsurface groundwater, and other factors. You can see here a stream that is cutting across this area, and sometimes these streams are recharged with the groundwater, and they can also give you an indication like where the water can be present. All right, so this is there is a well you can see here, and this well may be drilled conceptually, and you can see that this well is cutting the line of water table, and you can also see there is a dotted line during drought period. जब आप कहते हैं कहत किसी एरिया में पड़ गया, like the example is from Thar Desert, you can see that when there is no rain, the water most of the water wells they become dry. तो उसमें से जो water wells होते हैं they lose the groundwater, and as a result you can see the dotted line represents the water table during drought times. Okay, water table, as we have said, it is the upper limit of the zone of saturation. There are variations in water table, and the depth of water table is highly variable, and it also depends on the seasons. If there is a dry season, then the water table can go down. If it is a wet season, like there is rain present in an area, then the chances are there that the water table is very shallow, it is near to the surface. So it depends on seasons, it depends from year to year, and of course this is very important, the shape of the groundwater table is replica of the surface topography. So you can see here, if there is a higher area, the water table is also high, and as we move towards the downstream, तो जैसे ही आप देखें तो stream is very low, so the water level is also low here as compared to the level. It means the groundwater normally follows the surface topography. If you have an hilly area, it means the chances of finding a groundwater in that hilly area at a shallow depth are more than at deeper depth. So you need to understand the topography, the rock types, the presence of, and of course, there are also the presence of adjacent wells. You can see that if there are other wells that are present, and they have the water as well. So it's also the factors that contribute to the irregular surface of water table. Water tends to pile up beneath high areas, variation in rainfall, and variation in permeability from place to place. Permeability is a phenomena in which it tells you how efficiently water can flow out from the pores. If the permeability is low, water cannot flow. If the permeability is high, water will flow very easily. So that's the interconnection between the pores is called the permeability, or you can call it as effective porosity. So there is interaction between groundwater and streams, and it constitutes a basic link to the hydrological cycle. So there are gaining streams and losing streams. Gaining streams are those which gain water from the groundwater and increase the amount of water in the stream are called as gaining streams. There are other streams, losing streams. Losing streams are those like for example एक stream जो है वो ऐसे एरिया से गुजर रही है जहाँ पर already drought है, जहाँ पर खुश्क साली है, जहाँ पर water कम है, तो वहाँ पर जब वो stream पहुँचेगी तो most of its volume, most of its water will be reduced, क्योंकि वहाँ पर जो infiltration है वो ज़्यादा होगी as compared to the areas where we have wet soil. So just let's see the figure. Here is a figure that shows you the gaining and losing stream. Here we have a stream that is present just adjacent to the groundwater table, and you can see the blue color and the arrows pointing that the groundwater is supporting the stream. That's why the volume of the stream remains constant, the water in it, or almost it remains the, or it increases. Similarly, if there is there is some drop in water table, then there are chances that the stream will lose most of its water. And if the stream is disconnected With the groundwater table, because the groundwater table is falling so fast, the stream cannot keep up with it, and as a result, the stream and the groundwater table are disconnected with each other. Okay. So we just saw the two streams. There is another factor. The storage and movement of groundwater is the porosity. Porosity is the percentage of total volume of rock or sediments that consist of pore spaces. So it means if there are more pore spaces, it means more water can store there. If there is less pore spaces, it means less water can be stored there. So how much groundwater is stored in a particular place will ultimately define that how that area uh, is having a connection with the groundwater. Similarly, maybe recently you have seen that a private organization in Karachi, they made a private dam so that they can maintain the groundwater. Maintaining the groundwater is very important. You can have some streams adjacent to the big cities, or maybe small check dams that you can make with the large cities so they can support the water, and or you can also store the rainwater so that you can use that rainwater in the dry season. So there are some other terminology. Permeability, as I said, it is the ability of a material to transmit a fluid. Similarly, we have equitard. Equitard is a impermeable layer that prevents water movement. So equitard layers, sometimes they are present below the aquifer, below the water table, or above. Sometimes they are present above. So they prevent the water from moving from one place to another. Uh, those sands or rocks that contain water under the surface are called as aquifer. So finding freshwater aquifer is very important, and hydrology, hydrogeology, these are the subjects in which these factors are considered, and these are subjects that are very important for future. Hydrogeology, hydrology, these subjects, if we combine with the environmental studies of an area, are the future guidelines of human population on Earth if humans still want to live on this planet. So we just leave it here for today, and we will continue from here.